In this video, we'll be looking at the solutions for a system of linear inequalities. Now, it starts off very much like when we looked at linear equations, the system of linear equations. And just for a quick recap here, if we had two lines and we wanted to see the solution was where they met. Now, inequalities are similar. But instead of now looking where two lines meet, if we have one inequality that looks like this and another inequality that looks like this, the solution is where it gets shaded twice. The region that got shaded twice. So this region here. Very pretty artwork here. All right, so let's actually jump in and do something. Do a question here. Okay, so here we have two inequalities, and I want to see the solution for both of these inequalities as a system. So I can graph the lines as they are, but I prefer to graph them in slope-intercept form. I think I see a lot better that way. So I'm going to isolate the y in both of these cases. So we have at the top y is less than or equal to negative x plus 6. And that's my first inequality. Let's call that inequality, or I1 for inequality 1. All right, and my next one, I just have to divide both by 2, and we get that y is greater than a half x, or x over 2. All right, and I'm going to call that inequality 2. All right, so let's make this one first, inequality 1. All right, so we're going to start off at the point we know, which is that 6 right here. And our slope is negative 1, so it goes down 1 over 1, down 1 over 1, and it keeps doing that. All right, so we can draw our line. Awesome. Okay, so then the next one, let's draw the next graph in blue. And it starts off with an intercept of 0, so we'll get that there. And the slope is a half, so it goes up 1 over 2, up 1 over 2. And let's do one more of those guys right there. And the line is broken because, as you can see here, it's greater than a half. It's not greater than or equal to a half. So we have to make the broken line to show that it cannot be equal to that line. And so that broken line looks a little something like that. Not great, but you get the point. All right. But these are not equations. They're inequalities, which means that we're not just looking at or intersection point right here, we're looking at where the regions cross each other. So let's look first for y is less than or equal to negative x plus 6. Like, where is that region? That region is below that red line because it says y is less than. So it has to be lower than that line. So we can shade that right there. And then the other one in blue says that y is greater than a half. So that's the other side above, greater than, so above the blue line. So that is up here. So now we can see that our region, I'll outline it in black, is everything in the area that I just outlined. And it's infinitely many points in that region. So there's infinitely many points in that region that's a part of our solution. So to check this, as you should so wisely do whenever you're doing a problem that you're not familiar with, to check this, you would want to pick a point in that region, any point in that region, and see if both things hold true. So I am going to choose this point just because it has a 0 in there and it looks kind of convenient. So that's the point x is 0 and y is 2. So if our x is 0 and y is 2, this is in fact true. 0 plus 2 is less than or equal to 6. And we can try again here. 0 is our x and 2 is our y. And it is true that 4 is greater than 0, so that is also true. So it looks like we found the right region. Awesome.